Welcome to our Chapter 1.1 lesson video. It's called Introduction to Angles. We're going to talk about all the kind of basics you need to know about angles for our trig course. There's a lot of kind of introductory type stuff in here, some additional information to things that you might have already known. All right, so our learning targets for today is you can find an angle that are complementary and supplementary. Remember, complementary means we can add to 90, supplementary means we can add to 180. We're not going to review that too much. I can convert back and forth between decimals, degrees, and degrees, minutes, seconds. So we're going to talk about what that is, what it means to have a decimal degrees versus degree, minutes, seconds, and how to convert back and forth. And then I can find the measure of coterminal angles. All right, so first things first, let's talk about the parts of an angle. This is our basic angle structure we've known before. We have 3 points. The point that's kind of at the origin of the angle is called the vertex. Okay, when we talk about the name of this angle, we either say it's angle A based on the single point where it is, or we can call it angle BAC or angle CAB. All right, the side that we start the angle from, we call that the initial side. Now, it's not something we see too much in geometry, but that's something we use a lot in trig, is this is the initial side. And then as it opens up, that side that's kind of swinging out is called the terminal side. The angle that's created on the inside, we call that theta. That's just a variable like x. Theta represents an angle that we measure in degrees. All right, as we open our angles up, if the angle opens up in a counterclockwise direction, so counterclockwise direction, we get a positive angle. So as we open up this way, we get a positive angle. So this could be, for example, a positive 60 degrees. Now, if our angle opens up the opposite direction in a clockwise manner, we get what's called a negative angle. So in this case, instead of being positive 60 degrees, even though these two angles are the same, we could say this is also a negative 300 degree angle if we measured around in the opposite direction. So counterclockwise, we measure as positive angles. Clockwise, we measure as negative angles. Now, this is kind of a new topic to us. So usually we measure degrees 0 to 360 degrees. We could say something like, I have 75.2 degrees. That's just a way we could say it. We could go as many decimal places deep as we need. However, there's another way to measure our angles. We can use something called degrees, which is just the little circle like we've used all the time before. And then a subunit of degrees is called minutes. And a subunit of minutes is called seconds. So we have degrees, minutes, seconds. Okay, well, here's how that breaks down. In every 1 degree, there are 60 minutes. To mark a minute, we just do one little dash above our number. So 1 degree has 60 minutes, kind of like 1 hour has 60 minutes. And in every 1 minute, there are 60 seconds, kind of like on a clock. Every 1 minute has 60 seconds. So the way we would read this right here is 12 degrees, 42 minutes, and 38 seconds. Now, this is just another way to represent that decimal representation. They are equivalent ways of representing the same thing. This is just kind of a more precise way we can talk about these rather than kind of some random decimal that might not mean as much. Okay, so we're going to do 3 problems here. We're going to take this number, 74 degrees, 8 minutes, and 14 seconds, and we're going to change it to a decimal. I'll show you how to do that. We're going to take this number, 34.820 degrees, and change it into degrees, minutes, seconds form. And then lastly, we're just going to simplify this little expression right here. I'll show you how to do that. Okay, so these are our conversion methods. This is something you need to pay really close attention to. This should be brand new for most people. All right, so 74 degrees, 8 minutes, and 14 seconds. What we're going to do is we're going to keep the degrees part. So there's still going to be 74 degrees. That's not going to change. But we have this 8 minutes. This 8 minutes is 8/60ths of a degree. So we're going to take 74 and we're going to add 8 over 60 to it. This 14 seconds is 14/60ths of a minute, and a minute is a 60th of a second. So we're going to take that 14 and we're going to divide it by 60 times 60. All right, so to recap that, we have the 74 degrees. We're keeping it in degrees. The 8 minutes, we're dividing by 60 because this is 8/60ths of a degree. And then the 14 seconds, we're dividing it by 60 times 60 because a second is 1/60th of a minute, which is 1/60th of a degree. So if we calculate that out, we still have the 74 degrees, that doesn't change, plus that 8 over 60 is about 0.133, let's go 4 decimal places. And then that 14 over 60 times 60 on your calculator, you should have gotten that was 0.0039. Take all those pieces, add them all up, and you get 74.1372 degrees. There we go. We took our degrees, minutes, seconds, and converted it to a decimal. So once again, the way we do that, we keep the degrees, we add the minutes divided by 60, and we add the seconds divided by 60 times 60, which is 3,600. All right, now the other way of doing things is to kind of go back in the opposite direction. So to go back in the opposite direction, I'm going to use a slightly different color. I'm going to, first of all, I'm going to take that degrees off. So I have 34 degrees. I know that. Next thing I need to do is I need to figure out how many minutes I have. To figure out how many minutes I have, I'm going to take the decimal part, 0.820, and I'm going to multiply it by 60. So I'm going to take that 0.820 and multiply it by 6, and I get 49.2. All right, so what this tells me is I have 49 minutes. So I have 49 minutes. I'm going to take that 0.2 and I'm going to multiply by 60 again. 0.2 times 60, and that gives me 12, and this is my seconds. So in total, I have 34 degrees, 49 minutes, and 12 seconds. So this is taking a decimal and turning it into degrees, minutes, and seconds. So to recap how I did that, I just took the number in front of the decimal off, that's my degrees. I took the decimal, 0.820, I multiply by 60 because there's 60 minutes in a degree. I take the new part that's in front of the decimal, that's my minutes. I take the part after the decimal, I multiply by 60 again. Whatever I get, that's my seconds. And if there was more of a decimal, I would just round appropriately. So 0.5 and above, go up. Anything less, go below. So I get 34 degrees, 49 minutes, and 12 seconds. All right, one last little example problem we're going to do, and this is adding and subtracting with degrees, minutes, seconds. When you add and subtract with degrees, minutes, seconds, you kind of have to remember how many units of each one there is. So when I see this 90 degrees minus 24 degrees, 15 minutes, and 9 seconds, I'm going to rewrite that a little bit. I'm going to rewrite that as 90 degrees minus, and I'm going to line the degrees up, 24 degrees, 15 minutes, and 9 seconds. All right, the reason I do that is I'm going to do something that's kind of like old school math. I'm going to borrow from the degrees to make minutes. So if I take one of these degrees, turn that into 89 degrees, that'll leave me with 1 degree to work with. That means I can turn that into 60 minutes because that 1 degree from the 90 is now 89. I took that 1 degree, I turned it over here into minutes. There are 60 minutes in a degree. I'm going to do the same thing with seconds. I'm going to take one of my minutes, turn this into 59 minutes, and I'm going to give myself 60 seconds. I can now go ahead and subtract. I'll just subtract each column separately. So 60 minus 9, that's 51 seconds. 59 minus 15, that's going to be 44 minutes. And 89 minus 24, that's going to be 65 degrees. Okay, so to recap, what I did is I rewrote this. I took the 90 degrees, I lined up the degrees. There was no minutes in the first one, so I lined up the minutes and I lined up the seconds, but there was nothing in the top row there. I needed minutes and seconds to take away from, so I took one of those degrees, turned this into 89, made it 60 minutes. Then I took one of those minutes, made this 59 minutes, and turned that into 60 seconds. I can do that because if I take one of these degrees, one of those degrees becomes 60 minutes. And if I take one of those minutes, it becomes 60 seconds. That way I have something to subtract from. It's kind of like borrowing from a 10 back in when we did subtraction in like 2nd grade. All right, let's continue on. All right, some more information about angles. When we write angles in trig, we're usually going to write them in what's called a standard position. The standard position of an angle, so we talked about our angle earlier, it had an initial side and a terminal side, and then it opened up in a counterclockwise direction if it was positive, a clockwise direction if it was negative. An angle with its vertex at 0, 0, the origin, and its initial side is always going to be pointing to the right on the x-axis. We say this angle is in standard position, and wherever that terminal side ends up, we say that's where the angle exists. So this picture I have right here with this angle that goes through the point P on the terminal side is in quadrant 2. So our quadrants start in the top right. Quadrant 1 is where our angle starts from 0 to 90. Quadrant 2 goes from 90 to 180. Quadrant 3 goes from 180 to 270. Quadrant 4 goes from 270 to 360, and then our angles could keep wrapping around over and over and over. So again, our initial side is at 0 degrees here, pointing to the right, and then as we open up, we go from 0 to 90 in quadrant 1, 90 to 180, quadrant 2, 180 to 270, quadrant 3, all the way to 360, this is quadrant 4. Angles that are on the axes, so 90 straight up, 180 to the left, 270 down, and 360 back to the right, those are what we call quadrantal angles. They're not in any quadrant, they are in between the quadrants. All right, one last thing to talk about for today. We have these things called coterminal angles. So because we put these angles in standard form, as they wrap around and they start wrapping around over and over and over, the angles are going to start to repeat. Sometimes we can go in a positive direction, so counterclockwise. We can also go in a negative direction, clockwise, and angles will keep ending up in the same position. So this one green angle right here, for example, we can say it in a bunch of different ways. We can call it a 60-degree angle, which is what we call a least positive angle. That's an angle that exists between 0 and 360. So any angle within one positive rotation is what we call a least positive. So we could have a least positive 60-degree angle. We could also call that a negative 300 if we go around clockwise. Or we could wrap all the way around one time and all the way back to make a 420-degree angle. These angles that end in this same spot will all differ by 360 degrees, or one rotation. So really all coterminal angles, we would just add 360 or subtract 360 over and over and over to get all the different possible coterminal angles. So once again, coterminal angles differ by 360 degrees. If it's between 0 and 360, we call it the least positive coterminal angle. All right, go ahead and try and find the least positive coterminal angles for these two angles. So to do that, what you're going to do is you're either going to add or subtract 360 until you get back between 0 and 360. So you want your angle to be between 0 and 360. We include 0, we don't include 360, so we include the smaller one. We don't include the bigger one. So this first one, 908 degrees, what we're going to do is we're going to subtract 360 as many times as it takes to get back to 0 to 360. So if we subtract 360 once, that won't quite do it. We subtract 360 again, and we end up with 188 degrees as the least positive version of that angle. So 908 and 188 are at the same position. So if we were to draw that, it would be somewhere over here in quadrant 3. But they're the same position, they're just differing by 2 orders of 360. Negative 75, same idea, except this time instead of subtracting 360, since we're negative, we're going to add 360 degrees. That'll give us a positive 285 degree angle. So if we were to think about that, a positive 285 degree angle is somewhere over here in quadrant 4. So that would be going around this way, positive 285 degrees. And it makes sense that going negative 75, not quite a right angle, would get us to that same position. With that, you should have enough information to be able to get started on the assignment. You're going to need your textbook. I also included a PDF scan of the textbook in case you don't have it on hand on our Google Classroom. So please go ahead, get started, check it out. If you have any questions, I'd be glad to help you out or help you in class. In the meantime, I hope you have a great day, and I'll see you in our next live session.